Hi, so this is a quick video explaining how I use an LDR as the sensor on my RC race car lap timer. So basically the LDR works as a voltage divider. So what you've got is the LDR and a fixed resistance, and we're taking the voltage at the junction between these two and feeding it into the Arduino to start and stop the lap timer. We can predict this value here by using this equation. V in is R2 over R1 plus R2, and that's the voltage divider equation, and that comes from Ohm's law. So what I've done, I've set up a multimeter here to measure the resistance of an exactly the same LDR at ambient. So we've got 6.16 k ohms, so I'm going to write that down. Ambient equals 6.16 k ohms. Then I can shine a torch on it and we can see what happens. So with the torch on it, it's gone right down to 220, we'll say 225 ohms, because it moves about a bit. So with the torch, it equals 0.225 k ohms. So we're going to work in k ohms to help with the maths. So we can predict the value of V out using this equation. So if we do V in, well, we're going to actually measure V in. So if we use the multimeter again, we'll actually measure the value on the Arduino, because in case it's not exactly, so move it to voltage. So it's 4.86 volts. I'm going to move this to our V out position for later on. So at ambient, we would be V out equals 4.86 times 10 over 6.16 plus 10 equals 4.86 times 10 over 16.16. So 10 divided by 16.16 equals that, times 4.86. So that should be about 3 volts. And then we can do the same with the torch on it. So V out equals 4.86 times 10 over 0.225 plus 10 equals 4.86 times 10 over 10.225 equals, so I'll get the calculator again, so 10 divided by 10.225 equals 0.9779 times 4.86. So that should equal 4.7 volts. So obviously that's taken us nearly to the value of the full voltage. So if we move, so we're now on V out in ambient, and we've got 3.2 volts. So this connection here is at this junction here. So that compares quite favourably. Obviously the sensor's quite sensitive, so we might have had actual change in the light level, which has brought that value up above our calculated. Now if I get the torch and shine it on, that brings our value up to 4.6667. So we calculated 4.7. So that proves that what we've got is correct. Now what the Arduino does is takes that value and we put it into an analog pin, and the Arduino has a DAC, digital to analog converter, or analog to digital converter. And what we're doing there is converting a reading from voltage into a binary value. And I've got this little sketch here showing, if I just upload it, and it's basically giving us a value so if I zoom in, at the moment we're reading ambient, so it's about 690. Then if I shine the torch on it, that goes up to just under 1,000. And the way that we're reading a decimal value, but it's actually a binary value because it's a 10-bit. I've said it's a DAC, but I think it's a analog to digital converter. So, which is an ADC. So I'll cross that out. ADC. So these are what it's converting it to. So it's a 10-bit. So at full brightness you'd read 1023. When you convert 1111111111 into decimal, that's 1023, and obviously all zeros are 0. So for example, 1110110110 is 950. We can predict this value here using this calculation. It's just basically we take our voltage in, divide it by the maximum voltage, which is 5, which is the 1023 value, then times by 102, and that will give us our decimal value, so we can actually calculate those values. So for example, at our ambient we got 3 volts, so we can do 3 over 5 times 1023. Sorry, my writing's absolutely terrible on the video. So 3 divided by 5 equals that, times 1023 equals that. So we'd expect a reading of 613, and then obviously this one is 4.7 over 5 times 1023. So I'll get the calculator again. 4.7 divided by 5 equals that, times 1023 equals that, which is 961. So if we took, we about 600 and about 960. So if we check these, so we're getting just over 600. So obviously the light's gone up in here since I measured that first reading, and then if this will be more consistent because the torch sort of overshadows the ambient light. So we're getting 990, so the light's a bit brighter. So they correspond quite accurately with what we're reading. Our calculated values and our read values are about the same. This is a very simple little sketch. So all we're doing is we're just setting up a variable called sensor value. Then we start the serial monitor, and then we read A1 and put that in sensor val, and we just print it and delay a second. So we can just read off those values. So I'm going to close this down, and I've got another sketch to give you, to sort of go into it in a bit more detail. So in this sketch, we've got an LED on pin 4. And once again, we read the sensor value. And then if the sensor value is below 950, we turn the LED high. Or we turn it low and delay a second. So we're using that value from the analog to digital converter to turn on and off an LED. So this is the little setup. So we've got an LED here through a 220 ohm resistor onto the 0 volt, so that's on pin 4. And if I just upload this sketch, I've got an industrial control panel in the background, that's nothing to do with this project. So that's done uploading. I must admit I like these new USB connections. So we've got the LED on at the moment, so we can have a look at, open the serial monitor, and we can see the value. So that's 680, which is about what we calculated before. Now if we put the torch on it, that should take it above our threshold value of 950, which it does. So that should turn the LED off. So we've got the LED on here in ambient, and if I bring the torch on it, it turns the LED off. So torch on it, torch off it, torch on it. I think I've probably got that a bit right. So if I turn this value down, so if I make that say 900, make this 900 and then upload it, it's probably be a bit more reliable. So that's uploaded. Put the serial monitor on again. So go back to our Arduino. And that's working really well. And then obviously I use the same principle in on the RC car lap timer. So we have a torch or a light source shining at an LDR, and then as the car breaks the beam, that obviously sends the analog red value down, and we turn the timer on, and then obviously it goes around, breaks it again, and we turn it off. And I'm just using the Arduino debounce circuit sketch and modified it, added the LCD in, and instead of a button activating anything, we're working as a threshold value, and that then starts and stops the timer. So thanks for watching. I hope that provides some insight into how my lap timer works. Thank you. Goodbye.